Hello everyone. Now I am going to discuss about error control codes. This topic comes under in error detection and correction. Error control codes nothing but ensuring reliability in digital communication. In this communication, digital errors happen when bits flips from 0 to 1 because of noise or interference. Think of it as a digital hiccup that changes our message before it reaches its destination. Recap the digital challenge data errors in digital transmission, like frozen video calls or corrupted files, are inevitable. These glitches can have severe consequences in sectors like banking, financial loss or fraud, and healthcare. Misdiagnosis, patient hang. Then next discussion you might have said noise or interference in the channel changes, bits, hardware failure or signal degradation, financial loss, data breaches or safety risk in critical systems. In design thinking, first we discuss about the empathy map. Here, one person, that person name is Raj. He is a network engineer. He is managing a banking server. He cannot afford a single transaction error. For example, sender and receiver, two members are there. In between two members, they are sending messages through noise pollution. Bit may flipped. It can cause the error. The problem is data travels through noisy channel, the wireless or copper channel. Bits can flip from 0 to 1 randomly. This is the problem. The main goal is we need a mechanism that detects these flips and corrects them without resending everything. In defined phase, the core concepts are what are error control codes, the techniques that add redundancy to add so we can detect and correct errors. The strategies are error detection identifies that an error occurred. Example, parity check. In error correction identifies and fixes the error. Example, Hamming code. Here, parity check is the safety number. We add the number for checking the correct value. Then forward error correction, that is FEC. The receiver can correct errors without asking any sender to retransmit. The vertical depth Hamming code logic is P1 checks the bit is 1357 and P2 checks parity checks bits are 2, 3, 6 and 7. Parity bit checks bits the 4, 5, 6 and 7. Here is bit mapping from one between to another. In CD and DVDs, scratches cause errors, codes recover the music or movie data. Then QR codes. Even if part of the QR is dirty, your phone call still read it. Deep space. Problems use powerful codes to send data across millions of miles. In prototype, Hamming code activities are build the Hamming code. Scenario is we want to send the 4-bit data messages, that is 1011. These are the 4 bits. First, identify the positions for parity bits, powers of 2. Then calculate the parity bits even parity to cover the specific data positions. Then write down the final 7-bit transmitted code. Discuss with the partner how does this help us detect if 4-bit if bit 5 flips, true or false, and why. Adding redundancy bits to a message increase the bandwidth required but decreases the probability of undetected errors. Now it's time to explain why. Why? Because adding redundancy bits to the message increases the bandwidth required but it decreases the probability of undetected errors. Why is that means correct means redundancy adds extra bits ensuring reliability trading efficiency for accuracy. If incorrect means redundancy reduces bandwidth because the receiver processes the data faster. The answer is adding redundancy bits to the message increase the bandwidth required but it decreases the probability of undetected errors. Why is that means redundancy adds extra bits ensuring reliability, trading efficiency for accuracy. The summary and key takeaways are mind map, empathize noisy channels, corrupt data. In define phase, error control adds redundancy for reliability. In ideate phase, detection versus correction. In prototype, Hamming codes use parity positioning. In test, proven in real world uses. Final assessment. Question number 1. What is the primary purpose of adding redundancy bits in error control? Second question is which code allows the receiver to correct errors without a retransmission? Third question is in Hamming code, where are the parity bits typically placed? The first question answer is to detect and correct errors in transmitted data. The second question answer is forward error correction, that is FEC. Third answer is at positions that are powers of 2, that is 1, 2, 4, 8 and 16 like that. Thank you for watching this video.